Heyo, heyo, iPad Initiative Geometry students. This is your favorite teacher again, Mr. Lane, here to do another exciting and fun lesson. This is going to be similar to section 4.4 and all the different shortcuts for the triangles. This one's going to be over angle, side, angle, 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 side, and the hypotenuse leg theorem, which is going to be A1 over the right triangles. So as always, make sure you get the title wrote down, make sure you get number 5 written down and answered if you want full credit on those notes, and be paying attention for that secret word. It might be anywhere in the lesson. So let's get to rolling here. One definition is the included side, which is common side of two consecutive angles in a polygon. So we're going to be talking about triangles mainly here. So let's mark a couple of angles. Boom, boom. So the included side, what would be trapped in between those two angles? Well, this one's not trapped between those two angles. This one's not trapped between those two angles. It would be this side that would be trapped between those two angles. So that's what we call the included side. Let's see, so for the angle side angle postulate, notice we have an angle, the included side, so make sure that we got the included side followed by the other angle. Look at the diagram down here, we got an angle, we got another angle, the side is trapped between the two angles. Notice that is not one of the sides that are outside of those two angles, so the side in between is the included side, has to be the included side in order to use angle side angle. Let's see, we got one example here about a mailman has collected mail from mailboxes at A and B and dropped them off at a post office at C. This table gives enough, or does this table give enough information to determine the location of the mailboxes and the post office? So it's asking basically, is this a unique triangle? Do we have angle side angle marked? Because that's all we have so far in the lesson. Let's talk about bearings just for a second. We must know our directions, so you've probably all heard a little saying to help you out, as in never eat, bad E there we go, never eat sour watermelon. So those are the directions on your page that we follow, and they're going to give us our initial side of the angle measure, and where it opens up on these bearings. So we want to start off with somewhere called A, and its bearings to get to B says that if we had this north line, straight north, then we'd open up 65 degrees to the east to get to B. So this would be 65 degrees here. And then it says to get to B to C, so from here we head north again, and then we open up 24 degrees to the west. So this angle right here would be 24 degrees. And then that's going to get us to point C right there. And then it says to get from C back to A, we head directly south, and then we open it up 20 degrees. That's going to take us right back to A, by the way. So this is 20 degrees right here to the west. So what we got to do is we got to find all these angles that we're missing in the triangle, especially this angle right here is the one we're really after, because we're given that from A to B is 8 miles, which would be the included side between A and B. So how are we going to find that? That's the best question. Let's see, number one, it looks like I've got any of these north and south lines are going to be parallel with each other. So we can go ahead and mark those as parallel, and that's going to open up all those angles that we learned in the last chapter. For instance, these two are parallel lines cut by this transversal, so that these would be alternate interior angles. So this right here I would know would be 24 degrees without much work at all. Another thing I would know is here's another parallel lines, the red and the blue one. So this 20 degrees would also be this angle right here, because those are alternate interior angles. Now the red and the green are also parallel lines, so the big angle right here and the big angle right here would be same side interior. And what do I know about same side interior? You're absolutely right, they add up to equal 180 degrees, so they're supplementary. Well, if I added the 20 degrees that I know for this angle and the 65 for this angle, that would give me 85 for that big angle right there. So what does that allow me to do? Well, I know that if I call this angle x, then x plus this little piece right here, which is 24, would have to combine with that 85 to equal 180. So I'm just going to put it in here as x plus 24 is equal to that 180. Now I can add the 24 and the 85. I believe that will give me 109 degrees plus my x would equal my 180 degrees. Now if I subtract the 109, boom, that's going to give me 71 degrees for x, and now I know the angles that I need to, because this is now 71 degrees. But let's just make sure that it forms a triangle, so let's add up all the angle measures and make sure that it adds up to 180. So I'm going to have 71 plus looks like 44 there for that angle, plus the 65 in here for the third angle of the triangle. And if this all adds up to 180, let's see, that's 115 plus 65, boom, that's 180. So now I have all the degree measures that I need, and it shows that it's a unique triangle, especially since I have the angle, the side included, and the angle right here. So let's keep moving. Regular geometry class students, boom, right there. Looks like 2, 3, 9, and 10. iPad initiative, we're going to move on to another example. We got to determine if they can use angle side angle, and I think I was supposed to have this marked right here as congruent, so I'm going to put that back in here. And I think that's all the markings that I would have. So if I only have two angles here, the only side that I could get congruent with itself would be the reflexive property right here. So I'd have to mark it congruent to itself, but that's not the included side. And there's no way that I could say that these two sides here, which would be the included sides, are congruent. There's no property or anything like that that I could name for that. So I'm going to say no, we don't have the included side. And that should be a good enough explanation for that. So let's move on. Regular geometry students, boom, right there, 4, 5, and 12. iPad initiative, we're going to move on to angle, angle, side. Now the difference between this one and the last one we talked about is angle, angle, side. Notice that we don't have to have the included angle now. So we have this is congruent, this one's congruent, and it's a non-included side. If it's a non-included side, then we've got to use angle, angle, side. So that's the difference between the last two, is that now this is not going, it's going to be one of the other sides, not the one trapped inside the two angles. So pay attention for that. Looks like we've got a little proof here. It says that we're given this information. We're trying to prove that these two triangles are congruent. Let's mark those two triangles real quick to highlight them. Alright, so we're marking these triangles here. It looks like I've got X, Y, Z. I'm going to outline it a little bit. Maybe I should use the highlighter. And then we've got, let's see, V, Y, W. So I'm trying to show that the outside two here is congruent. So how am I going to go about doing that? Number one, I'm just going to put the whole given down for my first statement and reasons. So I'm going to go right over here, a little 2 column. I'm going to go statement and reasons. I set this up a little bit ahead of time here by copying it. So this is my number one, and my reason for number one is that it's given to me. Now I had one little typo on here that I've corrected, and it's this angle here should be YZW. So anyways, I've got, let's get a different color here so it kind of stands out. I've got the X is congruent with the V in the given. I've got YZW, which is right here, is congruent to YWV, which is right here. So I'm marking that stuff. Now I've got segment XY right here is congruent to segment VY, which is right here. So it looks like I've got all the information, not much of a proof here, because I've got angle, angle, and the non-included side. So I've got everything I need to make my final statement, which is triangle XYZ is congruent to triangle VW or VYW. And reason for that, I'm just going to put AAS, which is angle, angle, side. Alright, regular geometry students would be doing 6 and 13. We're going to move on to the last postulate here, which is the HL. The HL, it has to be the hypotenuse and leg, and another key to it, it has to be a right triangle. If it's not a right triangle, we cannot use the HL postulate. So it's got to be a right triangle. We've got to have one leg. We've got to have the hypotenuse. Remember, the hypotenuse is opposite always of the right angle. It's always the longest side. So that's what we have to have in order to use the HL theorem. Let's see, it says determine if you can use the HL congruence theorem to prove that the triangles are congruent. If not, tell what else you would need to know. So let's see here. This first example, we've got right angles. Check number 1. Check number 2 would be the hypotenuses congruent. So we just need one of these two legs congruent. Well, it's not marked, but notice that they share this side right here. So we could say that it's congruent to itself by the reflexive property. So we would have enough to use the HL theorem based off of the hypotenuse is congruent, one of the legs with the reflexive property of congruence, and then the right angles to make it a right triangle. This one here, it looks like maybe the outside ones are what they're wanting here. Notice that we've got one of the legs marked, we've got the right triangles, but we don't have any way to show that the hypotenuses, the sides opposite of those right angles, would be congruent. So we would have to have these outside sides congruent here. So we're going to say no, need outside sides congruent. Need maybe the right and left, something like that. Congruent. Boom. So we don't have enough information for that. Let's see, regular geometry students would be doing 7, 8, 14, and 15 at this time. iPad initiative students, we're done. It looks like there's our up one, down ones. By the way, if you didn't catch a secret word, it is mouse. Mouse is a secret word because I can't hardly use it to write. So mouse is a secret word. Email it to me first person, 2 points. Got it? Catch you later. This is Mr. Lane signing off from OHS High School. Bye.